modules, and I'm going to basically break it up into a couple of different sections. So the first section is going to talk a little bit about um, the way in which you can create a module. That would just be bare bones creating modules, okay? And that's something that is covered in most texts. Most texts that I have seen start off relatively advanced. So if you feel that the texts are a little advanced, then this would be the place to start. Most of you already know about modules, so this is repetitive information for this is going to be repetitive information for most of you. Okay, so that's a module, and then we are going to start making one. Let's start off by talking about the reason why you want to create a module. So let's go ahead and save this first. Where is my programming folder? Haskell programs, and then tutorials, and there should be something called modules. That is this directory right here. Okay, so when I create something over here, you're going to see a file pop up right there. So there you go. One thing that you might want to notice is that this saves the file as Unicode. Okay, so this is UTF-8. You can do UTF-16. This is more of an operating system thing. So if your operating system supports this, then it's very good. If your operating system does not support UTF, then it's like Windows, for example, supports UTF-8, so you would be able to port code between Mac and Windows if you leave it to UTF-8. If you go ahead and do UTF-16, then it may not be possible, okay, to port applications. So just so you know, you can save save a document as Unicode. So let me just keep that in mind because we're going to be using that right now. Okay, and so save it as main.hs. You can call it anything you want. You don't have to name it main.hs. Okay, so there you go. That's main. You see that over here, and if you do a list, you'll see main.hs. It's the same exact thing. It doesn't have anything within it right now. So the first thing that we're going to talk about is the other thing that you might want to consider doing if you are where is that? Preferences? If you are using Haskell, you might want to use this thing called auto expand tabs. Every good programming editor is going to have that feature. So as a result, this auto expand tab, what it does is that it takes a tab. Every time you type a tab, it's going to put in 4 spaces instead of a tab. Okay, so that's something that you might want to do if you are working on Haskell. So the first thing that we are going to look at is a couple of things, is how to, or why do we need modules in the first place. Okay, well, you don't really need modules in the first place. It just makes life much easier. So for example, you have a print function. So you can go ahead and do a main equals do and then print, and you can print something, whatever. Um, that that thing over there, that print, is imported from somewhere. Okay, so you can go ahead and write your own print function, but that would kind of be a little difficult. That's just putting it mildly. Okay, so that's something that you might want to think about. That's kind of the reason why you need modules. A lot of modules are imported right away when you load GHCI or Haskell. A lot of modules are not imported implicitly, so you have to go ahead and explicitly import them. And but the idea of this tutorial is to talk about how you write your own modules. Okay, so this section in this tutorial is going to talk about how you go ahead and write a module, create a module, the bare bones requirements for creating a module. That's what we are going to do right now. So anyway, we kind of covered that, why we need modules in the first place. Then let us look at I'm going to go ahead and upload this information in the video that I'm going to post. So you can have the programs and you can play around with the programs, so it's all cool. So let's start off by, well, let's not start off by making a module. Let's start off by writing a piece of code and seeing if we can modularize that, if you will. So what we want to do is we want to take a look at a couple of things. What we want to do is we want to write a function. Okay, so let's just run this. And it runs right now. So what we want to do is we want to add a function. Okay, and we will just look at a relatively simple function. So we want to take the dot product, okay, of a vector. So how do we represent a vector? The vector is going to be relatively easily represented right now. That would be your vector. Okay, so that's one vector, and what you want to do is you want to take another vector, and the dot product is just going to return a float. Okay, so that's your function. That's the type of your function. And just so you know, on the Mac you can just go ahead and put this thing over here. That's a Unicode character, and because Haskell is fully Unicode aware, it's going to take that and then it's going to be able to use it. So that's just a dot product. Okay, you have to implement the function. So you go ahead and say if you have two things, and y1 and y2 and y3, and the result of that is, and this is just theory, I'm not creating some new function over here. Plus x3 into y3. Okay, that's the definition of a dot product. Okay, so we can go ahead and see if we can run that. Okay, it's a very simple function, and then we just want to see if that code is working at all or not. and we've kept things relatively simple, so they should work. 2, 4, 5, and over here we put the unit vector 0, 1, 0. Okay, so let's see what this gives. So it has done this properly. So this is something relatively easy. We can go ahead and let me just put in the cross product as well. So the cross product is going to be somewhere over here. Let me just drag the cross product in. Okay. And the cross product, as you know, returns a vector. And not just a scalar, so that can be represented like that. And this is, oh, wrong, x2 into y3. Not x3 y1 x1 y3, and that one is x1 y2 and x2 y1. Okay. They should not have a y1 over here. Actually, y2. 2, 3, 3, 2 should be okay. If it isn't, it's okay. And we also want to check whether the cross product is working. And this may be wrong. I'm not sure. I did not think too much. It looks okay. It looks okay. Anyway, so that's not the idea. The idea is that we create a function, and we are working with vectors, and we realize that we are going to need these functions in a number of different places. Okay, so so that in the next step, what we're going to do is we're going to take these functions and create a module with them, so that we no longer at any point need to the copy and paste these things in another program anymore. Okay, so I'm going to talk about how to do that. So we go ahead and try and figure out why we would want to make a module. Of course, you have written this one program, and then you kind of say, okay, I'm going to make a new program. And so let's go ahead and make a new program. There you go. And you can say, you know what I can do is in this new program I can just copy paste this stuff, right? What's the big deal? I can copy paste this stuff, and when I have this stuff over here, then I can just save it. There you go. I can go ahead and save this as something like and then I can go ahead. So there you go. So now you have, as you can see, you have two files. Okay, and I can always do a different function over here. So and then I can write my own function over here. So yes, you can do that, but if you have 100 functions that you need, that you've already written, then it's kind of a pain to copy paste from different files all these things. So what you can do over here is go right ahead and say you just do that and save it, and you have written your module. Believe it or not, this is an actual actual module. So all you have to do is go back to your function and say import vector. That's the name of the module that you just created. Okay, you see, module vector, that's the name of the vector of the module. So you create your module and then you don't need this anymore. Okay, so now when you do a run Haskell, okay, it's still going to print the same thing. Just so you know, I'm not cheating over here. You can go ahead and make that, actually keep that one and just make that 2. Okay, you see, it has imported the functions from here, like right over here. So you do not have to go ahead and copy paste your functions anymore. So that's the easiest way of making a. So this is the end of part 1 of the tutorial. The next thing that I'm going to talk about is how you hide the implementation of your vector. Hello all, and welcome to my next section in the tutorial for modules. And what I wanted to do today is to, in this section rather, is to talk a little bit about data hiding, and that's something that's vitally important to writing manageable Haskell code. And why would I talk about this? This is something that is a very recurrent theme in Haskell, so it's probably very important that you get to know it as soon as possible. Okay, so let's think about this. Right now we have two files. We have one file called main.hs and another file called vector.hs. Okay, the main.hs assumes that you have a vector that is given by a 3 tuple with 3 floats in it, and given 3 floats, you are going to go ahead and provide 2 functions, the dot operator and the cross operator. And each of these functions, given 2 vectors, or rather given to 3 tuples, what you're going to have is you're going to have operators for the dot product and the cross product of these vectors. Now, for certain reason, you think that, well, so then you go ahead and use these functions, the dot product and the cross product, in many other of your programs. For example, main1.hs, main2.hs, and so on. Okay, you can name them whatever you want. And you've been doing this because you've been working on, for example, electromagnetics. And on one particular project, you realize that you are working on polar coordinates, which is also a vector, except that it is a 2 vector, so it has 2 floats instead of the 3. You can kind of hand wave it and say, okay, I'm going to use the first 2 and I'm always going to put 0 in the third element of the vector, and you can kind of get by until you get another project where you start working on digital signal processing, for example, or 4 vectors. You start working with on QED, and then you say, okay, we need 4 vectors. Now let me just put in one more float in there. And the moment you do that, what happens is that your previous code, all the code that you had written previously, main.hs, main1.hs, main2.hs, and so on, all of them break down. They don't work anymore. Okay, because now what vector.hs assumes that you have is a 4 tuple instead of a 3 tuple, and that's a problem. Then again, you say, okay, well, I'm starting to work on signal processing, and I start working with vectors that are 100 dimensions big. So am I going to use a 100 dimensional tuple, or am I going to use a a matrix, okay, or an array, or am I going to represent it with a list? You have a ton of different choices, but the moment you change, this is the basic thing. The moment you change from a 3 tuple to anything else, all the code that you've written with, as far as a 3 tuple is concerned, all the code that you have written, assuming that you have a 3 tuple, is going to break. Okay, you are not going to have any way of going back and changing it anymore. So you have to rewrite all your programs again, every single program that you've written. And this is something where code maintenance comes into the picture. So what do? What you do is you go from a representation that assumes that you are always going to have a 3 tuple to something that is that you have no idea about what the data representation is going to be. Okay. However, you have accessor functions. So for example, in this picture, we have vector.hs, which gives you accessor functions, make 3D Cartesian vectors, for example. That would be a vector representation of a 3D vector, or make 2D Cartesian vector. That would be a 2D representation of a Cartesian vector, and so on. You can give the other modules functions that will allow you to represent data in whatever way you want. You export these functions, so you export make 3D CV and make 2D CV and the dot product and the cross product, but you do not export the way in which you represent data. The way in which you represent data is not accessible anymore to any of your functions. As a result, you are free to go ahead and change the way in which data is represented. Okay, and as long as all you have to do now is, instead of changing all your code that imports vector.hs, all you have to do is change one function, make 3D CV, for example, that will convert the previous representation into the new representation. Okay, and then so you only have to change one file rather than all the files that you have. So that is what we are going to look at next. So here we are. We have our module. Its name is vector, and we have a couple of functions that we call from another function, another file. And what we want to do over here now is to convert this module, this whole module over here, into something that is a little easier to modify. Okay, so let's go ahead and see how we can do it. The reason why it's going to be a little difficult to modify as it is because of the fact that the data, like we discussed previously, the functions are tied to a particular data type. So if we change the data type at any point of time, that is a 3-tuple, then all the functions which refer to this this file is going to break, and we have to redo programming for all the other files that import this module. So what we're going to do is we're going to take this file and change it so that it becomes easier to change the module and not break all the other functions that already access this module. Okay, so of course we've already identified the problem. The problem has to do with the fact that the data expects to be written as a 3-tuple. Anytime something like that happens, what you want to do is you want to go ahead and create a new data type. So we do that with the keyword data, and we say that's the data type. Okay, and we would create a Cartesian coordinate, a 3-dimensional Cartesian coordinate vector. So we will call it 3D. So it's something like v3d cart. Okay, it accepts 3 floats. It's going to accept 3 floats, and is going to return you data of data type vec, which kind of represents a vector, of course. And so there you have it. So this is something that you can go ahead and create your data type. And one thing I haven't told you yet is anything that you want to export, you put in over here. Okay, so if you do that, if you go ahead and do that, then what it's going to export is everything within the module. We will go ahead and do that for now. We'll come back later and change that. Okay, now of course, now the good thing about this is that at any point of time we can come ahead and say, okay, we need a 2D vector, and we can keep adding different types of vectors over here. We can create another data type and so on. So this is the idea. We can, if we want, we can change the way in which data is represented at any point of time. Okay, but how do we access this? Okay, we are not going to give users an idea of how this is represented. Okay, so what we give users are what are called accessor functions. So we will create an accessor function which will be something like 3D vec, Cartesian vector. Okay, is something that will take a float and another float and another float, and is going to return this type of data. Okay, and so we define it. Relatively easy. Just takes A, B, and C, and it returns, uses the function over here, and returns a data type VEC. Okay, it takes these things, uses this function to create this data type over here. So there you go. We have a function that we say, okay, well, if you want to create a vector, what you can do is you can use this function over here. Okay, this is something that we export explicitly. and we are also going to export something else. Oh, give me a sec. I think for now we don't need that. And what we are also going to do is we are going to create a class. Reason being that, let's say we create another data type, and we say n is something like that. Okay, and we want this to behave like a vector also. Now, so for that we will create a general type class using the class keyword. We will say that's the vector class that we are creating, and we are going to define that if anything has to be let's just get rid of this for the time being. Okay, if any data type has to be a particular, it has to be of this class, then it needs to define, when I say class I mean type class. Okay, it needs to define that function and that function. It has to define that. Okay, and whatever data type you have over here, it doesn't really matter. It will take that and it will take that again, okay, and return a float. And this thing over here, the cross product, is going to look like that. Okay, so over here we do not specify that it is going to be a vector. Okay, data type having of type vector. It can be any type of data. It can be a number, it can be whatever. Okay, so now there you go. We need to make this data type an instance of this type class. Okay, so how do we do that? Instance, and we have to give the name of the class or type class of which we want to make this data type, and then over here we have to put that. We have to put this where, and we have to create our instances. Let's get rid of this for now. Okay, and let me just show you how easy it is. So first of all, we don't really care about definitions because the definitions are over here. We have to follow these definitions. So the dot product expects a vector, so you can create the only way in which we created a vector was like that. Okay, and this is a float, so we don't have to worry about this. And for the cross product, we have kind of the same thing. It's not a truth. We have this, and it doesn't line up. Okay, and we have that, and it returns a vector, so we have to create 3 numbers over here with what we want to do is we want to export this and we also want to export the vector class and everything within the vector class. Okay, everything within the vector class would export all these functions over here. So now we have a module that is a little more quote-unquote modular. So we go ahead and change the main function. So we're still going to import vector, but what we're going to do is we're going to take this function which we have well, actually we have not exported that. We ended up exporting the wrong function. We have to export that function over here so that we can call it from here. We say there you go, and that is a vector. That is another vector. And I just deleted the dot product. And then we can go ahead and print A cross B. And everything, if everything went out okay, if everything was fine, then this should print the cross product of A and B. Okay. In vector.hs we are not in scope. FL OAT, and we should be good to go. No instance for arising from the use of print. Okay, so we will say we will tell it how to print it, and hopefully there you go, that's the answer. We can do one more exercise, and we can say we want to load the module vector. Okay, now if you want to look at the type class, now this is interesting. If you want to look at the type class for or it's not the type class, is the type of make 3D CV. Okay, you get that. If you want to check out, you see, it's going to take 3 floats and give you a vector. Okay, you want to say, okay, what is vector? And you say you don't know. Okay, it won't tell you what vector is, how vector is represented. Okay, all it is going to tell you is I'm going to take 3 floats, I'll give you a vector, I will not tell you what vector is. And that is the important thing. It handles vector like a black box. You create ooh, what the hell? Um, 2, 4, 5. Okay, now you create a vector. That thing is creating a vector. You see, that's a vector, and you can use that as a as something with a data type vec, but you have no idea what happens inside vec. So anyway, so this is the end of the middle section. Now in the next section, what I want to do is I want to tell you a little bit about the overall structure of Haskell program. Hi all. So this is going to be the last section of the modules tutorial, and over here we're going to talk a little bit about what a Haskell program should kind of look like, if it's relatively complex. So what it really is a bunch of modules that are quote-unquote glued together with your main program, so to speak. So you have a program, for example, called program.hs, and as you can see, it imports module 1, module 2, module 3, and any other modules that you have. And you generally would like to import modules qualified as M1, M2, and so on, so that if you have function names that are similar in different modules, then they will not clash when you import all of them into the prelude or into the program at the same time. So that's one of the reasons why you would want to do a qualified import rather than just a direct import. Once you imported your module, then you create your main function, main equals do, and so on. Then you go ahead and write all your other functions that you need to create your main function. And remember that your whole program, program.hs, can be exported as a module. So you go ahead and give the program a module name. For example, it can be module ABCD or whatever name you want to give it, and you only export main. What happens as a result is that when someone else wants to import whatever you've written within program.hs, then that person can only import main, and main is the function that you would call to get this program working. So even over here you see that you kind of hide all other functions that you have. Main can use whatever functions you have within within the program.hs, but anyone else does not have access to all the other functions that are within main. So this is kind of what you want to be looking at when you're looking at a program. Again, a relatively complex program, and this is kind of the layout of what you should be aiming at. So there you go. This is the tutorial on modules. If you have any comments or questions, please go ahead and write them down in the comment section, and thank you for watching. Bye bye.